So what if the future of AI isn't about getting bigger and bigger? What if it's actually about getting smarter and much, much smaller? The entire industry seems obsessed with building these massive city-sized models. But a fascinating new paper from researchers at NVIDIA is challenging that whole idea. And honestly, it could completely change the game for AI as we know it. All right, let's get into it.
First things first, we really need to question this bigger is better mantra that's been driving everything in AI. Right now, pretty much every AI agent you interact with is powered by a gigantic language model running somewhere in the cloud. But there's a huge, kind of hidden cost to doing things this way. Just look at the numbers. In 2024, the AI industry poured $57 billion into cloud infrastructure. And why? To support a market that was only worth $5.6 billion? That's a 10-to-1 investment ratio. It's this massive economic disconnect, right at the heart of the market, that everyone's just kind of accepted as the cost of doing business. The researchers have this perfect analogy to describe the problem. They realize that most of these AI agents are doing really simple, repetitive stuff, like parsing a bit of data or making an API call. So using these massive do-everything models for these tiny jobs is, and I quote, like using a Formula One car to deliver pizza. Yeah, it's incredibly powerful for sure, but it's also wildly inefficient. Okay, so if the giant models are total overkill, what's the alternative? Well, this is where the NVIDIA paper really makes its case. The solution, they argue, is to make a fundamental shift towards small language models, or SLMs. Now, before we go any further, let's get really clear on what we're talking about. The paper gives a super practical definition for an SLM. It's not about the number of parameters, not really. It's about its usefulness. Can it run on a regular device like your phone or your laptop? If the answer is yes, it's an SLM. Everything else? That's an LLM. Simple as that. The whole argument for making this switch to smaller models is built on three really compelling pillars. Let's break them down one by one. First, and this one might actually surprise you, modern SLMs are already powerful enough to get the job done. I mean, we're seeing models like Microsoft's 7 billion parameter Phi 3 getting performance that's almost on par with models 10 times its size. Especially for specific tasks that agents do, like tool calling, that performance gap is closing incredibly fast. Second, it turns out small models are actually a better fit for the kind of work agents do. Think about it. Agents need predictable, consistent outputs in very specific formats. You can fine-tune a small model to be an expert at exactly that, without all the extra overhead of general conversation skills that it just doesn't need for the task at hand. And third, well, the economic argument is just undeniable. Serving a 7 billion parameter SLM is anywhere from 10 to 30 times cheaper than a 70 billion parameter LLM. And this isn't just a small saving. We are talking about a massive reduction in cost, in latency, and in energy use. It's a huge deal. Now, this whole insight doesn't just change the models we use. It changes how we even think about building entire AI systems. It's not about a simple swap, one model for another. It's about creating a fundamentally smarter architecture from the ground up. And to be clear, this isn't about getting rid of large models completely. No way. Instead, the paper proposes building these smarter, heterogeneous systems. Picture a central controller, kind of like an air traffic controller, that directs tasks to the right tool for the job. It would use these small, specialized expert models for all the routine stuff, and only call in the big, heavy-hitting LLM when you truly need complex, general reasoning. The real-world implications of this are just huge. It means AI agents could actually run privately, right on your own devices. No more sending your data to the cloud. It means lower costs for businesses and for you. It democratizes AI development, letting more people innovate without needing a massive server farm. And it leads to a much more sustainable and responsible AI ecosystem overall. So, if this approach is more powerful, a better fit, and way more economical, you're probably wondering, what's stopping us? How do we actually get from where we are today to that future? Well, the paper doesn't just present a cool theory. It gives us a practical roadmap. It's a pretty clear 4-step process to convert an existing agent from a single giant LLM to this much more efficient system of SLM specialists. You start by logging what the agent is doing, you find their occurring patterns, you fine-tune expert SLMs for just those patterns, and then you deploy the new, super efficient system. Of course, the road ahead isn't without its bumps. The technology is pretty much there, but the biggest barrier is just inertia. The AI industry has already bet billions upon billions of dollars on these centralized, large model way of doing things. And, well, that kind of investment is really hard to just walk away from. And all of this leaves us with one final, really provocative thought. What if we've been thinking about AI all wrong? Maybe the path to AGI isn't about building one single giant, all knowing brain. Maybe instead, it's about creating a collaborative swarm of tiny, hyper efficient specialists all working together. It's a powerful idea and one that could totally redefine the next decade of AI.